Thank you. Thanks, Christine. Okay, let's get started. So, as Christine mentioned, I sort of have two heads. One, I'm curating APSQ.io, and I'm hoping that you're a subscriber. If not, I obviously hope you will subscribe after that session, or go to the website and subscribe right now. And then, secondly, I'm also Chief Product Officer of API security company Food2Crunch that's organizing this webinar. So what I will do, I took like half a dozen sort of large representative API breaches, vulnerabilities that have been reported in the last 3 months. It's not an easy. It turned out to be not that easy. Every week we report typically a couple of those. So 13 weeks in a quarter. That's like 25, 26 breaches or vulnerabilities reported. So I want to take to pick like half a dozen to fit into one webinar, but make them sort of representative or kind of recognizable brand names, etc., etc. And then we'll talk about each of them. And I'll also, since I work for Food2Crunch and Food2Crunch is organizing this webinar, I'll talk a little bit about how Food2Crunch product can help. But again, it will be on the high level. It's not a product webinar really. So I'll mention the product, but I will not go into detail or do demos or whatever. So a little bit about what product has, just for your context. So Food2Crunch API security platform, it basically goes end to end, like it helps you with REST API security end to end. From development, we have plugins for IDEs like VS Code, IntelliJ, Eclipse, other JetBrains IDEs, etc. We have and those plugins help with sort of static analysis, security audit. So while developers are working on the APIs, they can have security checks right within the developer environment. We have conformance scan, which is dynamic testing, scanning of the actual endpoint to again find vulnerabilities in the endpoint. And so both security audit conformance scan can be integrated into CI/CD, so you can do your tests while once you committed your code, etc. And finally, we have our API firewall for Food2Crunch protection. You put in the line of traffic, sort of as a gateway kind of thing, or as a sidecar proxy to your microservices deployment, and it protects the actual endpoint in production. So I will be mentioning those terms, the security audit conformance scan protection, during the webinar. So don't be afraid that this is what I will be talking about. But again, I won't really spend much time on that. Okay, let's get started. So this one is sort of, so as you can see, it sort of got reported on April 3rd. So it's technically, I guess, no, that's not Q1, but since it has been such a big story, I couldn't help sort of mentioning that in the Q1 scope. Facebook. So as you can see, this is a screenshot of the Facebook's actually official statement on their website. So this is a big deal. So on the hacker forums, etc., 530 million profiles of Facebook users got posted. That's obviously not the first time that Facebook got into kind of similar situation. And this time it was big enough for them to publish an official statement, as you can see, 3 days later. And if you read it, basically what they're saying here is that since kind of APIs were used to obtain the data, to scrape the data, then it's not really a hack, which is kind of weird, because obviously APIs are a way to hack systems, and is one of the primary attack vectors. So saying that when APIs are used, it's not as bad as when you have whatever your database breached or your network breached. It's kind of weird. But let's go into the details of what actually happened. So back in the day, if you remember, You used to be able to use your Facebook phone app, and maybe you still are. Actually, I don't have the Facebook app on my phone anymore. To find friends, which kind of makes sense, right? And Facebook obviously wanted to sort of growth hack and get as many users and as many friends, friend connections in the social network as possible. So basically, the basic idea is you have your app, your Facebook app. You obviously you have your contacts on your phone. Contacts have their phone numbers. Facebook has phone numbers on the records on their server side in the network. So why don't use the app to send your contacts phone numbers via Facebook API to the Facebook network, and then get back the matching profiles. Right, it makes sense. So most of your friends are probably in your contacts list on your phone. So kind of makes sense as a scenario to quickly find them on the network. So what went wrong? Hackers could use that API, right? So hackers could use the API and just submit random phone numbers. Obviously, a phone number is just a number, right? You take the country code, and then there's area code, and then there's the 7-digit the phone number. So there's only so many country codes. There's only so many area codes, and then again, phone numbers is just 7-digit number, so you can iterate through that. So you just generate them one by one, and you create those fake phone books, and then you submit them for APIs, and you get the profiles back. And again, some reports were mentioning that there's no official kind of full statement, but some researchers report that it looks like up to 10,000 entries could be obtained per one API call. And so you just have to make so many calls to get those 500 million records. Leaked data included names, Facebook IDs, phone numbers, email addresses. I've seen some reports that page likes could also get retrieved. And looks like Facebook has been receiving actually those vulnerability reports for a long time, for years. They fixed that finally in 2019, but for a long time, I've seen some reports that they were reported the vulnerability, but they were saying that that was not a big deal because the API kind of worked as expected. They actually, as I mentioned, this was the scenario they specifically designed, right? That they wanted this API to work. They wanted this scenario to work. This was the kind of the user story that they wanted to implement to get growth, to get people find their friends easily. So they were thinking that that's sort of a public data anyway. People put their names and phone numbers and email addresses on the pages. So they thought it was a legitimate scenario, and it took them years before they realized that this was a vulnerability, and they fixed it. The business impact. So it turned out that not all of that information was public. So even if users set their phone number visibility to not public, if they set their visibility to whatever to be displayed to friends only, connections only, or even if they just use that to whatever display to me only, or only use as a second factor of authentication, which a lot of security focused people ironically did. Those phone numbers, Facebook's API still use those phone numbers, even second factor authentication phone numbers, to match users, and thus they also leaked in that huge data leak, which is obviously a big privacy violation, and potentially all that data, as you can understand, like if I have a data of 500 million users with their names, phone numbers, email addresses, and their likes, things like that, I can do massive phishing attacks. Like I can send them bulk emails and text messages using that information. So that is potentially dangerous, and we will see how that plays out. But I think obviously that should only increase pressure on Facebook politically in the US and in Europe. So we'll see. But I don't think that will be easy for Facebook and nice for them. Okay, how to prevent that? I mean, obviously, this has a bunch of OWASP top 10 vulnerabilities. One is that it is so looks like authorization was not checked, right? So regardless of the level, like the level of privacy and access on the record on the phone number that users set was ignored here, right? So anyone could match and get record of anyone else, regardless of how their phone, of the privacy level of their phone. So it looks like some sort of internal API that was used there in the process didn't do the privacy check, the authorization check. Obviously, excessive data exposure. So way too much information was sent and available, and lack of resources and rate limiting, right? So I assume there was some rate limiting, as with any API of a large company like Facebook, to prevent kind of denial of service attack. But here, whatever, hundreds of millions of records got retrieved, and probably with a lot of mismatches on the way, etc. That could have potentially been detected. Okay, so what could be done against that? So first of all, obviously authorization, right? So make sure that any API that accesses some resources does authorization checks, even if it's an internal API, right? And obviously, like a testing tool could help here. And then to prevent excessive data exposure, define what the API is supposed to send and set the limits. For example, if an API returns an array, set the limit on the number of elements that the API can return. And you can define that, and the security audit can check that you've defined those limits, and then scan can test that, and protection firewall can enforce that. And implement rate limiting, right? Again, rate limiting is something that you can do with the photo-query protection, and also pretty much any API gateway can do that, at least to some extent. And some monitoring, right? So again, obviously, a lot of SIEM systems, a lot of systems that can help you with the monitoring and alerting. Photo-query can integrate with them. Surprisingly, there were, again, this quarter, there were a couple of similar vulnerabilities and APIs being used to scrape data. Parler, obviously, that if you remember the news, the events back from January, when there was that whole a transition from presidential transition in the US with all the events in Washington D.C. and Parler as a social network used by Trump supporters got a lot of attention and was shut down, etc. So regardless of the political views, basically on the security side, I guess people who were viewing Parler and Parler users as a threat, they scraped all the messages in the system and turned those over to police effectively. And so scraping turned out to be extremely easy because, again, Parler used sequential IDs. API was wide open, and even worse for the users, all the materials in the Parler, all the photos, videos were in raw format with all the metadata, like the date and place that they were taken, the devices used, etc., etc. So again, big privacy violation, and just unprotected API is super easy to scrape. Clubhouse. So Clubhouse, we'll talk about another Clubhouse vulnerability later, but just this week there was a whole, again, Clubhouse similar to to Facebook. Their profiles of 1.3 million. Okay, the word million is missing after 1.3. 1.3 million Clubhouse user profiles got scraped. Again, Clubhouse uses sequential IDs, so making it very easy to scrape the profile. And these are open to API scraping. All of that profile information is considered public by Clubhouse. So there, again, the names, but also links to the Twitter and Instagram accounts of the users, which can be private. A lot of people have their Twitter and Instagram accounts, some people at least, that don't explicitly state their names. So they treat those as sort of private profiles. Now, if they also are using Clubhouse, someone can find out that these profiles belong to them. Okay, so that's enough for the first use case. Again, those with Parler and Clubhouse, they were again another thing that I mentioned there is sequential IDs. Don't use sequential IDs, right? Making it far too easy to just iterate. You can always use just random IDs. Would at least be a little safer. Okay, another Clubhouse issue that was later early in the quarter, early in Q1. So as you know, Clubhouse is sort of that social network where you can talk to other members in the network and sort of have those live discussions that are sort of ephemeral, that they're not other people can join, but it's not sort of those discussions, those conversations are not published on YouTube or anywhere. So if don't join the room, you're not supposed to be listening to that conversation. And once the conversation is over, it's gone. Like it's not supposed to be available to anyone anymore, right? So it gives you that sense of privacy and intimacy, and that conversation is happening now or never, and no one else but the people you see in the room can listen to. So attackers found a way to get into the rooms kind of invisibly and get that audio stream available to them even without sort of being visible in the room. And they actually even had a website where they would stream those audio feeds to anyone who wanted to listen. And so the reason that they could do that is that the way that Clubhouse is organized is that you have the Clubhouse app, but that app actually doesn't do the actual audio streaming. So the app gets you. The app is basically the kind of the social network. So it helps you find those rooms, follow different people in Clubhouse, etc. But once you want to actually listen to the conversation, to get the audio data, you join the room, you get the token from a different system that does the audio streaming, Agora, and then you use the token to actually get that audio stream from Agora. So these are two different systems actually maintained by two different companies, and you're just getting the token and then using the token to join the stream. And so what attackers could do, they could just get through all the channels, get through all the rooms, and just join the room, get the token, leave the room. But the token, the Agora token, still worked. Those are independent. So use the token to get the audio stream. And so effectively, they could see all the conversations and get the tokens to get the audio from those conversations and just do whatever they wanted, right? Because those, again, disconnected systems, you would leave the room, not be visible in the room anymore, but still get the audio. How to prevent? So obviously it is broken authentication, right? You're no longer supposed to get access to that audio stream, but you are. Again, recommendation is obviously to use standard systems or whatever. Just pay attention to that design of your token systems system and of your access to resources. OAuth is a good mechanism to learn and use, right? It has been designed for delegated access, and use short-lived tokens and prevent token reuse, etc. For example, again, if you're using OAuth and you use JSON Web Tokens, then you use signed JWT tokens to make sure that no one can play with them, and fake JWT tokens. Prevent token reuse by using, again, audience, issue, all those mechanisms for JWT protection are very, very much applicable. So no one else but that regional app and the regional user can use the token, etc., etc. And FootCrunch has JWT protections, and we'll actually talk about JWT a little bit more in the next use case. Okay, next one, number 3, Microsoft. So Office 365 Outlook, again, the report happened this quarter. The actual vulnerability happened before that. Likely this one was not something that, at least to my knowledge, something that was actively exploited. To my knowledge, it was a researcher who found the vulnerability, reported to Microsoft. Actually, 2 researchers found it in parallel, reported to Microsoft, and Microsoft fixed the vulnerability, at least to my knowledge, before it was exploited. What the vulnerability allowed the attackers to read get access and read mail of other users. So it's obviously a huge vulnerability. So what happened is that Office 365 use and probably still uses JWT tokens for API authentication, right? So that means that when you get an API call like this, right, you would get authorization header bearer with the JWT token, right? That's a big encoded string. And so it turned out that it accepted JWTs even without signature. And so your typical JWT would have 3 sections, right? The header section that would tell which algorithm is used to sign the token, and some other metadata. Then the actual token that would have information about who the user is and user's permissions, other claims, etc., and the signature. So you would have when those get base 64 encoded, you would get kind of three strings separated by dots, right? So that metadata, the actual token and the signature. And if you try to play with the metadata or with the actual data, obviously your signature becomes invalid, right? So what happened here is that the system didn't accepted JWTs that would be sent without a signature, with algorithm set to none and no signature submitted. And this is very dangerous because I can then just do whatever I want, put someone else's name, or whatever, admin, or I could use Christian's name and get access to Christian's email because there's no signature, so there's nothing to check. Right? And so attacker could construct a token, put someone else's ID, and access the email. How to prevent that? So, I mean, obviously, it is broken authentication, right? Just because you're using OAuth and JWT doesn't make you automatically secure if the way that you're using them is not correct, is not following all the security best practices. So, one thing that I would recommend is obviously, unless you are super confident in the way that you implement JWT checks in all your code, externalize that, or externalize that parallel to your checks. Make you do your checks in your code, but also have some sort of external checking for JWT policies to make sure that only the algorithm that you expect is used, whatever, and other checks, right? Like the again, patterns for the specific fields in the way that you expect them to be, specific fields that you need in the token are there, etc., etc. And I will not be talking again. Isabel and I did an hour-long webinar just on JWT security and JWT protections. So I recommend that you follow that link and watch that webinar if you're interested. It's a big conversation. There's so many ways that JWT security can go wrong. Okay, going to the next one, iPhone automatic call recorder. So that's it's a popular app for iPhones that allow people to record their phone conversations. Again, disclaimer, it's not coming from Apple, it's a third-party tool, but it is a popular tool. It's kind of one of top 20 popular business applications for iPhone. So they had the API call to fetch recordings, and this is sort of the way that this API call looked like, right? So you fetch recordings and you supply application ID and your kind of user ID, which is your phone number in that system. And so when you want to watch your listen to your recordings on the phone in the app, you click. There's a button that you click, whatever, access my recordings, and this is the kind of API call that it makes. And so that API that it used, the API of the cloud system, had no authentication authorization, which is obviously horrible. So anyone from anywhere could make that call and get a list of phone recordings, and even worse, the user ID was just a phone number. So if you wanted to get, like, if you knew that someone was using that app, you would just make the API call, use that person's phone number as the user ID, and you get the list of all their conversations, and actually recorded conversations, whatever they have recorded, and actually link to the Amazon S3 storage with the recording, which you could then use to download the recording, which is obviously horrible. Like you can, phone conversations can be very, very private and confidential. And the fact that you could get access to phone conversations from anyone using the app is a huge deal. Again, obviously broken object level authorization, right? There's no way you should be giving recordings of phone conversations to anyone but the person who recorded them. Obviously broken authentication, right? As I mentioned, it looks like the API was open, bad. And again, ensure that you have authentication. There are, again, APIs that sometimes developers consider some APIs to be internal APIs. Maybe they are used by other microservices of the app and not by the front end, etc. And so sometimes they think that if someone on the network is making the call, authentication is not required. Please always have authentication. Again, for the current security audit can find APIs that don't. And test against broken object level authorization attacks. So make sure that you test to see whether the user making the call is who they claim they are, and are allowed to access that object. Going to the next one, number 5, chess.com account takeover. So I'm a user of chess.com. I like playing chess. I like that website and that a mobile app allowing you to play with the computer or play with other users. So it's a fun way to pass your time, but it had a big vulnerability leading to full account takeover, including administrative accounts. So the API that they had, so basically they have, the system has the ability that they wanted to make it more social. So there's the ability to kind of chat with other users. So find your friend in the network and send them messages, etc., and then receive messages from them. And so for that, they wanted to give you a way to find the user, right? Find another user in the system. And so the API to find another user in the system returned not just whatever, some sort of ID or something. It returned a lot of information on the user, right? So you can see that it has the internal ID, it has the whatever the URL of the country, the URL of the picture, information on the last logon. We'll get to the session ID later on. name, location, date when they joined, etc., etc. And that's actually not the full JSON. And making it even worse, that included session ID. And the session ID was something that you could actually use to log in on that user behalf. So you could use that API to sort of find the user, and the way that the app used that API was just to find the user and then send a message. But in reality, if you looked at the traffic, you could get all that information, including the session ID, and then make another call to log in on behalf of that user. And it turned out that if the user was an administrator, you could actually log into a different website, the admin portal, the backend portal of chess.com, on behalf of that user. They use the same system, the same session ID works. And then you could do really anything, whatever, reset passwords for other users, delete them, change data, etc., etc. So big vulnerability, a full account takeover, including administrative accounts, because they returned way too much data in that API call. So that's an obvious excessive data exposure vulnerability. That API should not be returning all that data. There's no reason why to send someone a message you need to know all that information about that other user. So to prevent that, just define your responses, right? If you have a response, if you have an API where you need to find another user to send a message, figure out what is the exact data that is needed for that scenario and return just that data, and define that data. And then you enforce that at runtime, right? So your API firewall knows that that's the only data that's expected. And so if your API starts leaking data and sending more data back, then that response can be either detected and reported, or just outright blocked, depending on how you set up your firewall. And the final attack of for that presentation, for that webinar today, is a NoxPlayer supply chain attack. So that was pretty ugly. So NoxPlayer is a popular Android emulator for Macs and Windows, I think. Again, this it looks like this supply chain attack actually happened and was exploited. The vendor sent me a message that they don't disclose the details, but it all has been fixed. So I'm mentioning that that information that I got from the vendor, but I'm just using the information from the attack from one of the researchers who posted the details of what happened. So supply chain attacks is when you have a system that sort of can accidentally start including some malware and sort of putting malware on your machine, on your system, along with the code of the application, of the legitimate application. So here that relatively popular emulator, I think they claim that they're using, that they have more than 150 million customers. So basically they have an API to update the system, to install additional modules, install updates. And so when you launch that emulator, again, a very common scenario, it checks for updates, it gets the URL of the update to be installed, it downloads the update, and it installs the update, right? So that's the legitimate scenario. Somehow, and again, I don't know the exact details, but it looks like somehow attackers managed to modify the system, maybe using some other API call with some sort of a SQL injection or command injection, etc. They managed to somehow access the server and the infrastructure. So some users would get, instead of regular update, proper update URL, they would get a URL for attacker-controlled infrastructure, and instead they would get back not a legitimate update, but an update with malware coming from attacker's website. Obviously, very bad, right? So and kind of potentially get into SolarWinds kind of scale of issues. how to prevent that. So if you are on the vendor side, again, make sure that everything that you send, everything that your APIs return is defined as well. So a lot of companies, a lot of API providers, they think about what they get, sort of of the parameters that they receive from API consumers. And in this, obviously, that's what you should be doing, right? Defining what you expect to whatever to define the exact strings in the parameter, exact JSON schemas, etc., etc. And that can definitely help with protect your APIs from injections and so on. But in a lot of cases, the companies don't check what they send back, what the APIs return. And in that case, they should have, right? So they obviously know the URLs of their legitimate infrastructure. So those URLs that get sent back for the updates, they should have been defined using the patterns, the regular expressions. So they could only belong to these specific URLs, these specific servers maintained by the company, by the NoxPlayer company, Big Nox. In this case, this was not the case. And so any URL, once the attacker managed to get those malware URLs into the system, the API started returning malware URLs, which shouldn't have happened. Okay. Okay, so those were sort of the 6 plus 2 bonus ones for the Parler and Clubhouse vulnerabilities API breaches that we wanted to cover as use cases. I hope this was useful. It's always best to learn from someone else's mistakes and not from yours. And if it is useful, we'll hopefully start doing that on a regular basis. These are some additional resources. Again, APISQ.io, near and dear to my heart, something that I spend every day working on. So please follow us and subscribe, etc. OWASP APISQ Top 10, wonderful resource where you can learn about, again, what the typical attack scenarios on APIs look like and how to prevent them. And obviously, tools from Food to Crunch, again, the company I work in. So I hope you find them useful and hope you are already a customer or will become a customer. We have commercial tools, but we have also some free tools like IDE plugins, etc., that you can start using right away. With that, I'm happy to take any questions.
All right, we have a question that just popped up. Do you have an example of what type of security dangers or hacks and leaks exist on Internet Information Systems for Windows servers?
Okay, so IIS is a popular web server from Microsoft. So I think so. So I'm guessing that when you're asking about like general issues of the server itself, when the server is kind of hosting the APIs, etc. So I think what I was mostly talking was about the kind of vulnerabilities of the APIs themselves. However, I understand that obviously your APIs, when they're hosted on a server, you kind of get in potential vulnerabilities of the whole stack, right? The API itself, maybe the .NET framework or whatever you're using to implement that API, the web server, IIS, the Windows machine under it, etc. So in general, take care of the infrastructure. Obviously, your IIS can be configured in poorly and can lack the latest patches, etc. So these are not logical issues, but these are the issues that can be real. So make sure that it's locked down, it's fully patched, etc., etc.
All right, next question. Which of the OWASP API top 10 were misused in the NoxPlayer attack?
Great question. So I guess I'm okay. So that's a great question. I think so off the top of my head, maybe this one is sort of so that there was I expect that the initial setup when they sort of got access to the system and sort of slips the malware URL into the database, it was likely an injection attack. It was likely. Again, we don't know because again the only statement I get from the company was that this all has been fixed and is no longer an issue. And the researcher obviously didn't know because again the researcher found the issue when the URLs were already sort of the malware URLs were already in the system. So we don't know how they happened there. So likely an injection attack, but also later, like the second phase of the attack, when the malware URLs were already returned by the APIs. I don't think we have an entry for that in the OWASP top 10, surprisingly, because that's someone who circumvented attackers who managed to circumvent the logic of the API, right? The actual application logic got circumvented, and basically the data get poisoned. It's some sort of data poisoning kind of thing. So it's not an OWASP top 10 that second phase, but yes, it's one of the importance of data validation, not just for data coming in, but also for data going out.
All right, next question. Is there any API protection that also has machine learning capabilities that work as fraud or maybe for fraud?
Yes. So there are systems out there. So there are lots of companies in that space that have machine learning, artificial intelligence, anomaly detection systems. You would typically use them with your API gateway. You would
Did we lose you?
Okay, so by all means, keep using those.
I think you cut out for a minute.
Okay, I'm back now, right?
You're back now.
Okay, sounds good. So basically,
I thought it was just me.
okay, so there are systems out there that typically get that have some sort of machine learning, artificial intelligence, anomaly detection. Again, that technology is widely available today. Typically, you would connect them to your API gateway logs, and they would try to figure out to find some anomalies in the systems. I personally am a big believer in API security by design and deterministic systems, and making sure that your APIs are designed securely and you enforce that design through testing and runtime protection. But those systems can be augmented by some sort of machine learning to hopefully detect some anomalies when they happen.
All right. Next one. When we secure APIs using an API gateway, what kind of security would you suggest to put in place at the web server level so direct web server level API access is restricted?
Okay, so basically what you would do if you have some sort of, again, API gateway, web server with the API gateway, that sort of, then your calls go through that gateway, right? So, and then there's some backend. So first of all, make sure that your backend cannot be called directly, right? So you have some sort of like mutual TLS or some and IP whitelisting and other means to prevent those APIs from being called directly outside. and also augment that with some sort of API firewall if you can. That would typically do even more enforcement on calls coming in and going out, and JWT protections and all other things that I mentioned.
All right, next question. Seems like the vast majority of API attacks target the top 5 of the OWASP top 10. Is that your experience?
Okay, so basically, so the way that API, well, actually, any OWASP top 10 list is prioritized is that attacks that either happen more frequently or typically have bigger business impact. They sort of get to the to the higher positions in the list. So of API top 10, again, the top 5 would indeed happen more frequently or have a bigger business impact. So yes, that's actually by design of the list. So yes, well, when you start going through the list, again, pay the most attention to the whatever top 5, then look at the top 6, etc., etc. So that they're all important, but sort of yes, they are sorted in that way.
Great. All right, last question. How do security researchers expose vulnerabilities without getting into legal issues? Is there any immunity? As a developer, can I start exploring vulnerabilities in popular APIs?
So no, there's no immunity, and actually, so I mean, by default. So obviously, so there are two answers to that. One is that a lot of companies, they actually have kind of security issue disclosure programs. Some have those on their own, on their website. They might have some information, or in their terms of use. They might have some sort of a security page, etc. Some participate in public forums for the disclosures, like HackerOne, etc. So please check those, and don't violate the service. Sometimes you would, like some attacks, some issues, sometimes you would find just by looking at how, like, your own profile. So you would be using, so sometimes I would see that researchers would use a system for their own records, their own profile, and they would see that something looks like there's a vulnerability for their own profile, and then they would report that to the vendor. So that's sort of, if you notice something by just looking at the traffic when you were legitimately using the app for your own data, your own profile, it's typically also considered okay. But again, I'm not here to give legal advice. I've seen some researchers finding vulnerabilities, reporting them, and getting in trouble. So please check the terms of service and check what the company expects, and definitely don't touch like data from other users. I would recommend that you don't touch any data from other users, so don't do anything that could inflict any damage on production systems of anyone, and contact the company when in doubt.
Yeah, don't go out there and get in trouble. All right, guys. Those are all the questions for today. Thank you so much, Dimitri, and thank all of you for being here with us. Do you have any last words?
No, thank you all for joining, and let's make your APIs in the world a better, safer place.
Yes, and don't forget to subscribe and follow and keep in touch with us. Can't wait to see you all in the next webinar. Have a wonderful rest of the week.
Thank you.